Greetings and welcome to my new calculus channel. My name is John Gabriel. So, in the previous video, I talked about Dave Farina, who's also known as Professor Dave Explains, and I told you that he didn't really understand he doesn't actually understand the operations of arithmetic. All he has is a superficial understanding, just like you. Now, what you hear a lot of the time is your teachers telling you about pod mass or bod mass or whatever else they try to get you to remember in terms of which operations you need to do first. But no one ever talks about the derivation of the operations. In other words, which operation is the most primitive? Now, I know I've discussed this with you before, but I'm going to tell you exactly why everything is the way it is right now. So, um, these operations are combinations rather than processes dealing with measure. There, for example, if you say which is first, parentheses, brackets, etc. But we need to understand measure. Okay, and the first or most primitive kind of measure is that of subtraction or difference, right? So um, I'm going to give you an easy way to remember it. It's called SADM. Subtraction, addition, division, multiplication, okay? And I'm going to get rid of that just so that I can have more space. I'll come back to it later. Now, so difference is, for example, if we have a line segment like that, and we have a line segment like that, okay, then this here is the difference, right? So in other words, if this was P and this was Q, P minus Q is equal to D, where D is this length here. So what subtraction tells us, listen carefully, what subtraction tells us is what is needed to make the smaller length equal to the longer, the shorter length equal to the longer. And of course, if the lengths are the same, nothing happens, right? Because 0 is not actually a magnitude. It's not a magnitude. So nothing happens when you have 0. Okay. So that is subtraction. Now, what is addition? So remember, I told you it's SADM. So addition must be defined in terms of subtraction. So addition tells us what length is measured, pay particular emphasis to the word measured, by the whole added. So for example, if you had P plus Q, and I'm not going to just put a line here, if you had P plus Q like that, what this means is we need the whole of P and the whole of Q to measure, let's say, an extended line segment like this. P and, okay, so this would be P plus Q. Now, if we have either of these, then we can denote the other with a minus sign. So, for example, we can say that P plus Q is equal to P minus Q. In other words, we remove the need of Q that we don't have. In other words, we're adding it, right? Or we could say Q plus P is equal to Q removing the need of P. That's why we say these two are associative. And they're associative because they're both based on this property of subtraction, not addition. So the fools in university or professors and teachers don't really understand these things. And they talk about addition being associative, but it's actually associative because it's based on subtraction and because this is true. So what I'm saying to you now is that you can define addition, right, in terms of subtraction, but you cannot define subtraction in terms of addition. So how will you define P minus Q using only the subtraction operator? How will you do that? You can't, because unless you use a subtraction operator, unless you use a subtraction operator, you can't do it. So you can't, for example, say P plus something to get P minus Q. You can't say minus Q, because that means the difference operate. You've already done a difference or subtraction operation there. So that's what that means. So you have to have first subtraction, then addition, or sum, then difference, right? Okay, very good. Let's move on. Let me just clear the board again. Unfortunately, I don't have enough space. Now, division is the next process. And our division can be done in terms of either subtraction or division. And that makes sense, doesn't it? And what does division tell us? It tells us how a divisor measures the dividend. So let me give an example. It says that if P is divided by Q, then it tells us how Q and or equal parts of Q, equal parts of Q measure P, right? That's what it tells us. And to give an example, for example, if you said 13 divided by 5, that means, this here means, now notice I'm not going to use subtraction at all, but I'm going to use both. First, I'm going to use addition. This means that 5, this 5 here measures 13 two times, right? And using 3 equal parts of 5, all right? That means 3 equal parts. Why are there 3 equal parts? Because 5 is equal to 1 plus 1 plus 1 plus 1 plus 1 plus 1, 5 times. And we want these 3 equal parts, which is 3, right? That's how algebra works. Okay, so the final answer is 5 plus 5 plus 3. But the same problem is done very easy using subtraction. So 13 divided by 5 can also mean the measure done through subtraction. We could say 13 minus 5 minus 5 minus 3. Okay. And then we've measured 13. There's nothing left. We've done a complete measure of 13. That's what division means, by the way. It means a measure of the dividend using the divisor. Bet you didn't even think of that. Okay. Now, just as you can't define subtraction in terms of addition, you cannot define multiplication. You cannot define division in terms of multiplication. Okay, and I'll get to that in a moment. But first, let me tell you what multiplication is. So for that, I'm going to again reset the canvas. Now, so what does multiplication tell us? It tells us how the reciprocal of a divisor measures the dividend. Okay, a reciprocal of a divisor measures the dividend. So if you had 5, oh, that's horrible. I wish it would default to the thin one. It's kind of stupid that it defaults to the thick one. So if you had 5 times 3, times 13, that means 5 divided by 1 over 13, okay? And 1 over 13 measures 5 exactly 65 times. What it means is you can say 1 over 13 plus 1 over 13, etc., 65 times, and that's a complete measure of 5, okay? Or you could do it with subtraction. You could say 5 minus 1 over 13, 65 times, okay? 65 times. Excuse my handwriting. So you could do it with subtraction or addition, all right? Addition or subtraction. Then similarly, you can say that 5 times 13 is also 13 divided by 1 over 5. And what you're doing then is you're measuring 13 using 1/5. And again, you'll see that it turns out that it's exactly 65 times as well, right? Okay, very good. So now getting back to the previous question, can we define division in terms of multiplication? That would mean that we'd need to have something like this. We'd need to say 13 divided by 5 is equal to 13 times 1 over 5. No, that doesn't make sense. Is it equal to 5 times 1 over 13? No. It turns out it's not possible to define division in terms of multiplication, okay? So we've covered the operations. It's difference, sum, quotient, and product, or sum, addition, or subtraction, addition, division, and multiplication. And of course, what I've done is I've actually just summarized this in a graphic that you'll see over here. So it's subtraction or difference, addition or sum, etc. And then coming back to this, okay, this is how the brilliant ancient Greeks, my ancestors, understood the four basic arithmetic operations. And all other operations, whatever they are, exponentiation, roots, anything else, are derived from these. Okay, so now one final point. In algebra, we are able to do this sort of thing. Why? Because of that fundamentally important proposition in Euclid called uh, Proposition 12 of Book 5. So what it says is if we have any triangle like that and we have uh, parts of the sides which are in proportion, so let's say this side is in proportion to this side, we can just carry on adding the same side to this side and the same side to this side as many times as we like, and subtracting as well, okay? And that's perfectly okay to do. So that's in Book 5, Proposition 12. So, for example, if we had something like 8 over 12 divided by 20 over 24, right? That's actually equal to 192 over 240. Now, we could say, all right, well, 192 over 240. Now, all these operations depend on this proposition here. And all the four basic operations are derived using this scheme. So you can say 192 minus 40 minus 40 minus 40 minus 40, like that, over, because 40 over 50 is in proportion to 192 over 240. 40 over 50 is in proportion to 192 over 240, okay? And that would end up giving us what? 32 over 40, okay? And again, we could do another subtraction here and say 32 minus 8 minus 8 minus 8 over 40 minus 10 minus 10 minus 10, because 8 over 10 is in proportion to 32 over 40, and we get 8 over 10, right? And similarly here, we can reduce that by saying that that's equal to 4/5 by simply taking away 4 from there and 5 from there, and then we can just decide we want to go the other way and say 4 plus 16 over 5 plus 20, and that would equal to 20 over 25, and then again we could add 12 over 15 to this, so plus 12 over 15, and that would give us 32 over 40, and we back to that, and we could get back to this eventually, which is what we started with. So I hope I've given you a very good idea of this. In order to get a better idea, to get a very sound understanding, I encourage you to go to my academia channel, okay? So in my academia channel, you will find lots of brilliant articles, all right? And I'll put a link to two of them. One of them is called, it's actually for toddlers and adults, and it's called Unlocking the Mystery of Numbers, Fractions, and the Four Basic Arithmetic Operations. Now, this is actually included in the Ultimate Book of Numbers, to which there is a link. And the other one is called Theory of Fractions from Book 5, to which I'll also place a link. Okay, so that tells you now that the four basic operations do have a precedence, and they do all start with what? With difference, right? They start with difference. So you first have subtraction, and then the next thing is sum, which means addition. The next thing is quotient, which means division. And the last one is product, which means multiplication. So I hope you've enjoyed this little video, and that you'll realize now that Professor Dave doesn't actually have a clue why he does the things he does, doesn't have a clue why he said that multiplication is just repeated addition. It's not. It's actually a reciprocal division measure. Okay, so multiplication is a reciprocal division measure. And of course, division is really repeated subtraction or addition or both. So indirectly, multiplication is also uh, a repeated sum or addition. And so I've given you all these facts now. Lots of stuff to think about. If you're not already a subscriber, become one. Tell your friends about this channel. Click like. I have many enemies. Follow me on this, academia.edu. And till next time, my name is John Gabriel, and this is a new calculus channel. Goodbye.